Okay, good day, humanities. So today we'll be talking about the endogenic and exogenic processes. So I have discussed in our last meeting that both endogenic and exogenic processes are vital in shaping the way how rocks are formed, how rocks do look like, how is their physical appearance or their chemical composition is. So we will start with the endogenic processes. So the endogenic processes are the processes that involves or originate beneath the Earth's surface. So this is influenced by the convection current or the heat coming from the inner core. Okay. So definition, it is located or occurring beneath the Earth's surface. Okay. So there are two types of endogenic processes. We have the folding and the faulting or the tectonic movements. So they take place mainly along the plate boundaries, which are the zones that are not stable. Endogenic processes may cause many major landform features. Okay, when we say folding, this is when two forces push towards each other from the opposite side. So for example, one plate tectonic is involved, but there are two forces that push towards each other. So the rock layers will bend into folds. The process by which folds are formed are due to compressional forces known as folding. So compressional from the word itself, compression. So it is pushed towards each other. Okay, so here's an illustration of folding. Okay, so it looks or it folds like a cloth, right? So the movement here, the folding also affects the way the eternal crust looks like. Okay, so folding also results in the formation of mountains. Okay, I have here a video that shows folding in a demonstration. Okay, so he uses grains of sands to represent the layers of the earth. Okay, here he shows one plate tectonic boundary that has like a dense part on it, which is an ocean basin. Okay, so continental plate boundary. Okay, as the continental plate boundary pushes the ocean basin, subductant or beneath the Earth's surface, it folds the ocean basin. Okay. Remember that continental crusts are lighter than the oceanic crust. That's why it would not be pushed. So that would happen during a folding. Okay. So now let's go on to faulting. So faulting is very different by folding in a way that there is a break along it. Okay, faulting is a fracturing and displacement of brittle rock strata along a fault plane, either caused by tension or compression. A break in rock along with a vertical or horizon rock movement has occurred is called a fault. So a fault, there is a certain or specific line that tells the boundary between two plate boundary. Okay, plate tectonic, I mean. So there is a line that separates two plate tectonic. Okay, there are three different types of faults. I know you are all familiar with this because we have discussed this in our very first topic, which is the Earth and I mean the second topic, which is the Earth and the subsystems. Okay, so there are three types of fault. When you say normal fault, this is convergence, meaning moving towards each other. Reverse fault, divergence, moving away from each other. Tear fault, transform, slide past each other. Okay, so here's the illustration of the faulting. So these are other endogenic processes aside from the folding and the faulting. We have the volcanism, metamorphism, earthquake. Okay, so when we say volcanism or magmatism, this is the volcanic activity that creates the igneous rocks. It is also called igneous activity. Okay. This is this allows magma to rise up along the lines of weakness and intrude into the crust. Some magma may even reach the Earth's surface and some don't. Diba? We have tackled already the different types of igneous rock. We have the intrusive and extrusive. Okay, so when we say intrusive again, it is forming inside or beneath the Earth's crust. And when we say extrusive, it has been extruded or was formed outside or exited from the volcano, right? Okay, so magma needs to be released. Okay, so why does it need to be released? Because if there is a constant or the rising temperature and pressure within the earth would not be released, it would cause the earth to increase its pressure. And once it would increase its pressure, and it would reach the time where its pressure cannot hold it anymore, it has a possibility to blow up. Okay. So here's an illustration of volcanism. So this is how magma is formed or how magma rises up. So magma will always find a way to be intruded or to be extruded out of the volcano. Okay, so the magma coming from the inner core or the mantle will always find a way to be extruded. Okay, so here are the results of volcanism, which are the different types of igneous rock. Okay, when we say metamorphism, remember that it is always influenced by two factors. Okay, heat is the contact metamorphism, and regional metamorphism is influenced by pressure. Okay, so metamorphism is still an endogenic process. Why? Because heat and pressure involves or can be found beneath the Earth's surface. So there is pressure and heat applied on two geologic structures which lead to the formation of metamorphic rock. So here is an illustration of metamorphism that shows how heat and pressure both affects metamorphic rock formation. Okay. Now, earthquake. Earthquake is the very familiar, right, Satoa? Because we already know and experience, most of us have experienced earthquake. Okay, earthquake or seismic activity is the sudden shaking or vibration in the Earth's crust. When plates suddenly move past each other, the built-up strain is released along the fault and the rock fractures. Okay, so when there is a movement in the plate boundary, there would be minute or minute changes. Okay, so when there is a sudden release of pressure as time goes on or as time passes, it would release those energy into an earthquake. Okay, so I have here a video presentation that shows the very beginning and how the endogenic process has affected or affects our planet. Okay, 5 billion years ago. Okay, so those are the cloud of gas that was formed by the nebula. That formed the nebula, I mean. As it condenses, pieces of debris come together, forming the planet. And as the planet, or I mean the debris collisions, it would make the denser materials go in and like downward, right? Moving downward. That's why the layers of the earth was created. Okay, one of those hot new planets was our young Earth. And because of the formation of the gravity that we have created, or the young Earth have created its own atmosphere. Okay, with the creation of its own atmosphere, it allows for the Earth to be cooled down. Okay, it cooled down. Slowly, the hot Earth developed a cool crack crust. So those lines or puzzle lines are the tectonic plates. Okay, the tectonic plates are what we call as plate boundaries as well. So this is where some volcanic and tectonic plates are very active. So the heat from Earth's formation is still inside the Earth. Okay, it's still trapped inside our planet, form of the convection current. Okay, so that is an illustration of a divergent plate boundary. So it is currently spreading, and that is a convergent. Okay, so there is one that is subducting. Okay, when plates pull apart, okay, that is an illustration. There is a formation of landforms. Okay, when there's a formation of landforms, meaning there is a creation of another landform, okay, which we call the seafloor spreading. Okay, when continental tectonic plates collide, that is the folding, mountains rise. Okay, so folding happens when there is two continental plate. Okay, so there is the mountains that is the result of the two continental plates. Earthquake is also one of the result of those movements. Okay, when ocean plates converge, it would allow the creation of volcanoes. Okay, so two continental plates folding, and when there is one oceanic plate, it will create volcanoes. Okay, so tsunami is also the result of the movement of the plates. Okay, so now let's go on to the exogenic processes. So from the word itself, exogenic processes, exit. Okay, what I need you to remember is when we say exogenic processes, these are the processes that affects the way how rocks are formed or the landforms are formed outside the Earth's surface. Okay, okay. Phenomena that occur in the Earth's surface, it is considered destructive and are responsible for the aggregation and sculpting of the Earth's surface. Okay, we have the different types of exogenic processes: the weathering, the erosion, the mass wasting, and sedimentation. Okay, so the weathering, there's two type of weathering. We have the physical and the chemical weathering. So I have an example on the 11 competence. I told you that weathering happens, or from the experiment. I mean, from the experiment that we did, the rock or the tablet, the Baroka tablet, which is in powdered form, reacts much faster, right? It reacts much faster compared to the rock or the Baroka tablet that is not broken down. Okay. So what is the factor that affects the Baroka tablet or dissolve? It's is its surface area or the space. Okay, next is the temperature, right? So that is also how weathering occurs in rocks. There are mechanical processes or mechanical weathering and temperature that affects weathering to the plant. I mean to the rocks. Okay, so the physical weathering happens when rock is physically broken into smaller pieces. So you can see here a water that is collected in a rock would later on be frozen. And as you know, when water is frozen, the molecules would expand. Okay, why would it expand? It will find way, the water molecules would find way to be lined up. So it would expand, and then that would make the water molecule more solid. Okay, so when that expands, mudako siya, it would make the crack bigger. It could make the crack bigger, and the repeated expansion and contraction causes further rocks till to split. Okay, so there are factors that affect the physical weathering. We have the ice wedging, the release of pressure, growth of plants, animals, and abrasion. Okay, so ice wedging happens mostly on countries, like very cold countries. So if you notice in different documentaries presented on YouTube or in your TV, there are instances that houses in the cold countries are shown. Okay, most of those country are doesn't use cement. Okay, why do they not use cement? Because cement has the chances to be to have cracks. Okay, so when this cement have cracks, it has the ability to stock water. I mean, there will be trapped water inside. And if there's a drop of temperature, the water would expand, would become an ice. So as it expands, it would make the crack bigger. So that's why most countries in the cold countries or cold temperate countries is that they use or they prefer wood. Okay, they prefer wood, or for example in the Alaska, they uses what the igloo, right? So ice mismo ang ilang himuon as their houses. Okay, next is the release of pressure. Okay, this is also somehow like the ice wedging. The only difference is there is a constant changes in the temperature. Okay, this would happen surface rocky roads, rock flakes like onion layers. So this release of pressure usually happens at countries where there is a very hot temperature during the day and very cold temperature during the night. Okay, what happens when a molecule or a rock would be exposed to hot is it would contract. Okay, when a molecule or a object is exposed to very hot temperature, it would contract. Okay, so you can observe that class. I would give you an idea for an experiment, right? So you would make an iron, okay, an iron bar to be exposed. You would expose an iron bar in a very hot summer day for like 3 days or like 2 days. Okay, no rain, just very hot summer day. Or like in the morning, okay, the first thing you need to do before you expose the iron bar is you measure the iron bar. Okay, after you measure the iron bar, you expose it to a very hot area and you measure it again like in the evening or like in the early afternoon. So what would happen is that there will be changes at the measurement of the iron bar. Why? Because the iron would contract. Again, if something is exposed to very high temperature, it would contract. And if it expose and if it would be exposed to very cold temperature, it would expand. So what happens when a rock constantly experience changes of temperature is that it would flake. Okay, so mora siyang magpanit. Surface rock erodes, rock flakes like onion layers. So it will have like onion layers and it would fall apart, okay, from the rock. It's like the first layer of the rock is falling. Okay. Now the growth of plants. Root grows into rock cracks and push rocks apart. So there are some instances, like for example, in the roads, right? So there are some plants that grows on the road. So what happens is if this plant grow bigger, it has the ability its roots would also grow bigger as well. So when its roots grows bigger, it would make cracks on the road. So that is also what would happen if there is a seed that would be trapped inside a rock. Okay. Now, animals burrow and push apart rock. Okay. So animals, example like hamster, they burrow under the land. Okay. What happened is they has the ability to transport a rock from one place to another, and they also have the ability to break rock. Okay, especially those small ones. So they will tend to break rocks into smaller pieces. Next is abrasion. So abrasion happens when rocks are typically constantly colliding with other rocks. So what would happen is that it would have a smoother surface as time goes by. If you if you would observe at the rocks at a construction site, you would clearly see or identify that rocks are rounded, right? So there is only a small amount of rocks there that have the typical square shape. Most of the rocks are rounded. They have a smooth surface. Why? Because they are constantly exposed to the collision of other rocks, right? Rocks from construction sites are typically transported from time to time. So that's why in they are collided also from time to time. Okay, so chemical weathering is the process of breaking down rock through chemical changes. Okay, the very best example for chemical weathering is a nail, right? Pako, lansang. Okay, lansang or pako or nail is made out of iron. And if you expose the pako, the nail, into the air without the use of water, time would come that it would turn into red orange, so it would rust. Okay, matayan siya. Okay, this is because there is a reaction that happened between the iron and the oxygen. Remember, our planet or the air that we are breathing contains oxygen. So when iron is constantly exposed with oxygen, it would rust. Okay, so there are also different factors that affect chemical weathering. We have the water, the oxygen, the carbon dioxide, the living organism, and acid rain. So water are dissolution. Okay, water dissolves rock chemically. Okay, if you expose, so this is partly because water contains salt. Okay, water has a salt content, so it has salinity. So what happens is when rock is constantly exposed with this salt or the salt coming from the water, it would dissolve. So you can observe this when there's a rain. Okay, the certain part when there is a raindrop would make like sinkhole. It would have a hollow part. So that is how dissolution works. It dissolves rocks chemically. Now, oxygen. Rock that has the iron in it mixes with oxygen and rust. So that is my example for the nail. So most materials that has iron would typically react with oxygen. Okay. And when that happened, rust would also follow. Matayan. Next is carbon dioxide. So CO2 dissolves in rainwater and water, marble, and limestone. So carbon dioxide, okay, it will has the ability to weather marble and limestone. So example is also carbon dioxide has the ability to make limes or the air very toxic. Okay, inside a cave. So if you observe class, if you have experienced canyoneering or like exploring the cave inside, exploring a cave, there is only a limited number of people that are allowed to go inside a cave from time to time. Why is this so? Because the carbon dioxide inside the cave cannot be recycled or it is not recycled. So what happens is if there is an increase of carbon dioxide, it would make the air toxic and it will also affect the formation of the stalagmites and stalactites inside the cave. So that's why carbon or the entry of people inside a cave is very limited. Okay, next is living organism. You know that, okay, with relation to the number three, carbon dioxide, you know, or I know for sure that you know that we are breathing out carbon dioxide, right? We are breathing in oxygen and we are breathing out carbon dioxide. That's why when we go to a cave, we are breathing out carbon dioxide. So we're contributing to the increase of carbon dioxide to the cave. Okay, why is there is a possibility of increase? Because most cave doesn't have plants, and plants is the only organism in our planet. Special plants. There are other organisms. I mean, plants is one of the most commonly found organism that has the ability to recycle carbon dioxide or to use carbon dioxide, right? Okay, let's move on to the next one, the living organisms. Acids from plants and roots chemically weather rock. Okay, example for this is when there is like a dead animal. Okay, the dead animal. So this dead animal may have releases acids and toxins. So these acids and toxins may also affect the rock itself. Okay, so that's how living organisms contribute. to chemical weathering. Next is acid rain. So this is somehow related to carbon dioxide. Acid rain is a result of increase of hydrocarbon. Increase of hydrocarbon, which means air pollution. Okay, when this would happen, acid rain would form, and the acid rain has the ability to cause deterioration. Okay, deterioration of statues, right? Okay, so there are different. So now let's go on to erosion. So we are done with the weathering. Now let's go on to erosion. There are different types of erosion. Erosion by water. Erosion by water changes the shape of coastline. Okay, waves constantly crash against the shore, shaping the rocks around it. Okay, now erosion by wind. Erosion by wind carries dust, sand, and volcanic ash. Wind can sometimes blow sand into towering dunes. Erosion by ice. Erosion can erode the land in frigid areas and some mountaintops. Glaciers move slowly downhill and across the land. As they move, they pick up everything in their path from tiny grains of sand to huge boulders. And erosion by gravity. Gravity pulls any loose bits down to side of a hill or mountain. Gravity erosion is better known as mass movement. Okay, erosion simply means the movement or transportation of a debris from one place to another. Okay, here, the transport of sediment. Okay, so here's the difference between weathering and erosion. So the weathering helps to break down the rocks into smaller pieces. I mean pieces. Now, if that would happen, there is a possibility that erosion would occur, especially when there is the presence of water, right? Because most erosion happens after heavy rains. Okay, so regolith, when weathered rocks remain in place and remain in its pure state sediment. When weathered materials are removed from the site of the weathering. Okay, moving water is the main agent of erosion. People nowadays also become agent of erosion. Why? Example, people tend to, especially those who climb in the mountains. Okay, as they climb, there is a small amount of rock that would be transported. Okay, it would be transported down below because they are moving. All right. So if you are stepping on the land, na yung mga gagmay nga rocks that would be displaced, right? Mabalhin og lugar. Yeah, that's correct. That's the correct word. Weathering and erosion. Weathered rock material would be removed from its original site and transported away by a natural agent. Example of a natural agent is the moving water. Okay, so that is how weathering and erosion are interconnected or interrelated to each other. Okay, sedimentation. So after the process of erosion, the sedimentation process would follow. Okay, I'm sure that you're all familiar with the sedimentation process. So if you can observe class, endogenic processes have two rock types, the igneous and the metamorphic. While the sedimentation has the exogenic has the sedimentation. Okay, so this is the natural processes in which material is carried to the bottom of bodies of water and forms the solid. Okay. Just remember the different types of sedimentation. I mean the different process of sedimentation. But we start with the erosion. Next is deposition, followed by compaction, and third is the cementation, which makes the rocks hard, right? Cementation. Now we have mass wasting. Okay, mass wasting is sometimes called as the erosion by land. So what is the difference between mass wasting? Mass wasting is the movement of rocks, soil, and regolith downward due to the action of gravity. So from the word itself, mass meaning daghan. Okay, so these are like very big transportation of erosion of materials. So this is much bigger than erosion. Okay, we are sometimes confused about this one. Okay, mass wasting, the very best example of the mass wasting is a landslide. Okay, when we say a rock debris that are falling alongside the road, we would automatically say that it's a landslide, right? So we categorize all different types of materials that are falling, especially at the mountainous barangays that are falling downward or sliding downward, we call it automatically as landslide. But the general term for that is actually mass wasting. So how do I identify the different types of mass wasting? First is, so there is two words involved, right? In the landslide. Okay, the first one is we need to identify the material. Next is the movement. Okay, so in landslide, what is the material that is involved in the mass wasting process? It is the land. Next is the how, what is the movement? It is sliding. Okay, so that is why we called it landslide. Okay, factors that triggered mass wasting over steep and slope. So this is areas very common. Also, this factor is very common at the mountainous barangay. So if there is a very steep slope, there is a greater possibility of mass wasting happening. Next is water. Okay, water trigger, same as erosion, is also an agent of movement. Okay, rainwater adds weight to the and acts lubricant to the weathered materials. So it would allow for the materials or debris or weathered materials to be easily moved. Okay. Next is earthquake. It is a vibration that also triggers mass wasting and vegetation removal. Very good example for this is deforestation. Okay, so if there is deforestation, there is no land, or I mean, there is no root that would no longer hold the that would no longer hold the no longer hold the land, right? So if there is no root, there is a and if there is a large rainfall that happen, the large rainfall would lubricate those land. Okay, it would lubricate those land to be moved because there is no organism like a plant that would use the water. Okay, that would use up the water. Okay, that is how vegetation removal triggered mass wasting. Okay, classification of mass wasting. This is what I've said earlier. So slump and solidification, you can see here that it is only one word. Okay, so this is the only thing that you need to remember. Slump is a type of mass wasting that results in the sliding of coherent rock materials along a curved surface. Okay, so there is a curved surface. Solidification is the slow downhill flow of soil. Earth flow. Okay, so the first material is earth. The material that involved is earth. The movement is flowing. So how is this look like? When we say flow, it moves like a water, right? Because nga na ang water, right? So the very movement of a water is like flowing. So here there is a viscous flow of fine-grained materials that have been saturated water and moves under the pull of gravity. Okay, mud flow. So the material that is involved is mud and it is also flowing. So mud flow occurs when the mud travels down a slope very quickly. Next is debris slide. So it slides, so debris. There is no land that is involved. And debris flow, okay, it is also the same as the debris slide. Only difference is it slides and one is flowing. So it has like a mud on it, okay, or water that is involved. Rock flow, okay, there is rock or there is loose rock. Okay, what happened? This may be a result after a very heavy rain. Soil creep is the slow, gradual movement of soil or wriggle it downhill over time. So you can see or observe soil creep class at Baguio. Okay, what happens is that trees in Baguio most trees in Baguio City used to like stand straight or they are vertically facing. But as time comes, there is a constant movement of the land at Baguio. It looks like it's moving like diagonally. So soil creep, it is the slow gradual movement of soil. Okay, here's the process of sedimentation. Okay, so Exogenic and exogenic and endogenic processes class are both destructive and constructive. Destruction is not a bad thing. Actually, it is a way to create something. Okay, so both endogenic and exogenic processes might sound very bad, right? But those endogenic and exogenic processes allows for the formation of the planet that we know today. It also allow us for to live. Okay, so exogenic and endogenic, though they are both destructive, they have the ability to create. Okay, so it has the ability to construct another being or another landform. Okay, so that would end our discussion for today. I hope that you would find time to listen the video, and I'm very glad that you have reached the end of our topic. So this would be the last topic for our midterm. Okay, so our midterm would be next week, and I'm very hoping that you would look this video since we will not be able to meet at your scheduled time, right? Because kamura po yung mga alkansya ni if dili mo makamit. So, my next meeting, if we will have a next meeting, maybe I will give you a summative exam. Okay, just sort of review, especially for the 11 competence. I forget to give you an exam about the different rock types, but I guess I can give you that on after the midterm na lang so that you won't worry. Okay? So I hope that you will have a great day ahead, class, and I hope that you have learned something from our discussion today. Okay? Thank you, everyone, and have a great day ahead.